Might be working now. Let's see. Sorry about that. I think I was fine, and then my Comcast decided to crash on me. Let's take a look. Let's see. Not office hours. This one here. Hey. All right, so I'm going to be on mute here in the voice chat. Otherwise, you'd hear me twice. But I should be in the Discord voice chat if you want to hop in. I should be able to hear you over here over my regular speakers, and we'll see how well that goes. This will be fun. So again, sorry for the last minute change. I got 3 kids sick, and I talked with our manager of environmental health and safety who's trying to coordinate everything, and he said, go get a COVID test, and I'm on quarantine, and he'll let me know more. So hopefully I won't be gone long off of campus. We'll have to see. But he recommended I don't do the quick tests. I do like the 2-day test or whatever it is, but something or other that's supposed to be better. So hopefully that's working. All right, are you folks there on voice? Do you want to try it, or just if you have a question, you can hop in? I think we're back. Reset the computer, reset the router, reset my wireless extenders. What a nonsense. It's 2021 and the internet can't be stable. It's crazy. All right. So we're on to Chapter 2, how to write your first Java applications. So this one is a lot of material. There's a lot coming at us. So we'll spend a good amount of time working through some of the basics and looking at, hey, let's actually make our programs do something. And then at the end of the night, we'll talk about your first actual project, Project 1. Project 0 is just, hey, can you make the tools work? So that should go pretty well. And then, let's see. Oh, okay, I got some bitrate back. Am I back? F's in the chat for Comcast. It's going real well. All right, this will be fun. If it keeps cutting in and out, we can look at some alternatives, because that'll just be miserable. But hopefully once it's back, it should be stable. Not so impressed with Comcast, which is kind of a bummer. All right, so we're going to do Chapter 2. It's a relatively large chapter. It'll take us a decent chunk of the night, and then we'll talk about your first real project, Project 1. And don't forget, we got some quizzes due, the syllabus quiz and Chapter 1 quiz if you have not yet. Do 11:59 p.m. tonight. Looks like most people have gotten that in. That's good. All right, and then I do have some official office hours now. I gotta post those. So for Tuesday and Thursday, looks like 8 to 9 a.m. Seemed to work for a lot of people. Yeah, if it's not coming through, maybe pause or unpause or refresh. Ought to do it. Should bring you back. And then Wednesday, it looked like 2 to 5 p.m. This will hit most people, it looks like. But if that doesn't work, oh, hey. Back again. And dead. All right, let's check Switch Inspector. This will just be nuts. Okay. I'm sorry, folks. Yeah, this is just on and off, on and off. It is a wild ride. There's a storm coming through, apparently. So, yeah. Storms, I guess they don't mix. All right, cool. All right, yeah, so official office hours. I'm going to do Tuesday, Thursday morning, Wednesday afternoon. A lot of people. Oh, thank you so much. Karimo? Sarimo? I've got this really cool. Where'd it go? Backboard that I use. Put this thing behind you. It helps you sit up real nice. it's pokey too, which is funky. Yeah, Comcast needs the posture check. Let's see, maybe that'll help. I was not available most evenings. I wasn't going to do anything before 10. Just trying to get all my kids in bed, so those weren't great, even though they worked for a lot of other people. I'm just not around. I've got class Tuesday and Thursday nights. So this Wednesday slot up till 5 looks pretty good, and then these mornings, I think I catch most of the people here. And then if you want to do an evening time, I'm happy to meet after 10 p.m. By appointment. So if you want an appointment, suggest a few times that work for you. So don't just say, hey, can we meet sometime? Say, hey, can we meet this time, or this time? And maybe one of those will work for me. I'll do my best to try and squeak that in. Okay? So I'll post that. I've got some official office hours now, and we can go from there. All right, I'm going to fire up NetBeans, and we're going to start writing some code. Have some fun with it. I think I mentioned I did put out all of the course, or the textbook slides. They're out here for you, here in this content section. So I'll have all the YouTube links to the recordings exported out this way. In the lecture archive, and then all the textbook slides are here as well. So I'm not going to use the PowerPoint, because it tends to be, when I put PowerPoint on the screen, either it's so much text that I end up reading it, or there's text on there and then you folks end up reading it and not listening, and we're just bad at multitasking. So most of what I'm going to do, or almost all of what I'm going to do, is going to be in NetBeans. So I'll actually be writing the code as we talk about it. And I find that works relatively well for most people. But if you like the PowerPoint slides, they're there for you. So you can kind of use those as like a Cliff Notes version of the text. But please do be reading your textbook, right? We don't just assign a textbook for no reason. All right, we stable again? Maybe we're stable again. And I'm still getting used to this evening class thing here. So I've got a quad shot drink from my local coffee shop just around the corner. As you can see, I'm most of the way through those 4 shots. So please feel free to shout at me if you want me to talk about something again. I don't mean to speed over things. So, okay, I'm still in voice chat. Should be good there. I don't think anybody's chatted at me yet or talked to me. But if you want to Twitch chat, great, I can read your messages. Or if you want to pop into the voice chat, it'll be delayed just a couple seconds probably, but should be okay. All right, so it's looking better now. That's a good sign. Looking better. We're pretty stable here. 0 frames per second? That's a funny way to look at that. Huh. Right, I'll have it notify me, pop up if something goes wrong. All right, so I'm going to start a new project. Close all the other ones down here in these. See the negative latency? Are they that fast? That's crazy. It's like faster than your computer can keep up. They're sending the data at you. All right. Come on, NetBeans, go. There we go. All right, so I'm going to start up a new project. And remember, when you start a project in NetBeans, we're going to use the Java with Ant Java application. We're going to put it inside the repository directory. So for project 0, right, we put it in this project 0 directory. Sorry, that text is a little small there. But I'm going to put everything in my course repository that's public for you folks to see. So that's my 1500. Did I not make one? I don't have one. All right, my bad. I need to go make a repository for you folks. Thought I did that. Did I not do that? I did not. All right, I need to make a public repository then that you folks can see. Sorry, we only did project 0. That's right. We didn't get to that. So this is the step that the GitHub Classroom link automates for you. You don't need to go and make a repository every time, which saves us a lot of typing, which is really nice. So this will be CIS 1500 fall 2021. It's a public repository, so everyone will have access to it. I'm going to add a README file. I'm going to add this ignore file to say, hey, please don't add anything that we can build. And then mine I'm going to license just for fun. I think it's fun to pick the MIT license. That's a pretty good one here. We'll make the repository. Then in my GitHub client, I'm going to go clone that repository. I can either open GitHub or I can go from this nice little code button here, open with GitHub Desktop. I'm all about shortcuts, so I'm going to use this one here so it'll launch it right for me. I don't need to find anything else. So all the public examples I do, everything's going to show up in this new repository. So it says, hey, do you want to clone this one? Great. It's going to go in my documents, GitHub folder, CIS 1500, fall 2021. We'll clone it. Now that I've cloned it, I have that folder on my computer, and Git is going to watch for changes in that folder. So now in NetBeans, I can go to Browse, and I should have that folder here. 1500, let me just go back out. GitHub, 1500, fall, there we go, 2021. So anything I put inside of this folder, now Git is going to track. So we'll call this one Chapter 2. That is going to make a new folder inside of it, make me a new main class. This is fantastic. I like when the tool does all the work for me. Hey, my phone finally connected to chat. Probably don't need that now, since we seem a little more stable. Right, and in my chapter2.java file is all the code. Now, these are comments. Comments are going to get ignored by the Java compiler. So comments are just notes that you can leave for other people to read. So it tries to give you some helpful little, hey, you can get started here. I'm going to delete them because they bother me, and we don't need them. Okay, so really, all we need is this package line, public class chapter 2, curly brace. So everything inside this curly brace is going to belong to this chapter 2 class. We're not going to do anything with classes until chapter 6, 7. I used to know all the chapter numbers, but we changed books. So a couple of chapters later, we'll talk about what classes are and what they all do for us. So for now, everything we're going to do is just stuck inside of public static void main, parentheses, string, square braces, args, end parenthesis, start curly brace. So this curly brace and this curly brace is where all of our code goes. And it even tells us, hey, to do code application logic here. Here's where all the magic happens. Right? And then here we can give commands to Java to do stuff. And we can tell Java, hey, I want you to do this thing. Right? Or I want to store a variable. I want to have some piece of information that I'm going to use inside of my code. Right? So we'll look at an example, and then we'll go back and kind of pick it apart as we go. So I'm going to have use this scanner object. And remember, scanner is how we can get input from the user. And we'll call it, I like to call it keyboard. I don't know, Mr. Gaddis called it keyboard with a previous book. SC is a terrible name for it. But you can call it anything you want. This part here is the programmer assigned variable name. And when you come up with variable names, you can make them be almost anything you want. There's a couple rules about it. Excuse me. So they have to start with a letter, an underscore, or the $sign. Okay? Or that's the starting character, and then everything else can be those things or digits. So you can't start with a number, but you can put a number at the end. This could be like keyboard 1. Anything you want to call it. Only 255 characters or less. And it can't be any Java reserved words. So see all these things that show up in orange for us? These are all Java reserved words. They mean something special. So we can't use that. So the text has a whole section on reserved words. You can just look up, hey, these are the things we can't use for it. Okay? So scanner keyboard equals new scanner. And we're going to say system.in inside of these parentheses. So new is the keyword to tell Java, hey, go make one of these things and store it somewhere in memory. Go make a scanner. So this comes out of the library. Go set one up for me. And I want it to use system.in. That's our standard input, our keyboard input at the console. And now it all turns red and this mad at us. So we need to check this little light bulb hint. And it says, hey, do we want to add the import? Because if you hover over, it says cannot find symbol. Sorry, that's kind of small there. But cannot find symbol means Java doesn't know what a scanner is. So Java comes with a huge library full of really cool tools. So we want to add the import and say, hey, give me the tool called java.util.scanner. and it adds this line for it. You could also type this line by hand. I just would rather not type things if I don't need to. So it's importing the java.util.scanner class into our program. Now, usually we don't import everything all at once. Right? So we're only import the things that we want to make this go a little faster. All right, so now I have scanner keyboard equals new scanner given system.in, and then I still get a yellow line. Excuse me. NetBeans says, hey dummy, you have this thing you called keyboard, but you never did anything with it. So this is a helpful reminder. Don't click the light bulb and say configure my unused element hint and turn off the hints. That's a really helpful hint to say, hey, you're not using this yet, and that's okay. We aren't yet. So now I need to prompt the user for something, right? We want some sort of information. So I can use my system.out.println, or that's SOUT and then to finish completing that, right? And everything we want to print to the screen goes inside the quotes here. We're going to have this string literal. We're literally putting a bunch of text into our code here. We'll say, please enter your hourly salary or hourly pay rate. Okay, so we'll ask them to enter their pay rate. Then what we're going to do, we need to store that information somewhere. Now the problem, if you remember with scanner, is it only gets string input. It's only going to give me back string results. But I really want numeric things that I can do arithmetic with. So we're going to do some conversions here in a second. So there's two ways we can do it. The scanner class can automatically get numeric values for you, but I don't recommend you use it. You can run into all sorts of trouble later on using that, so we're not going to bother with that. So you do have the option. You could say, hey, I want a double here. So double is our preferred type for numbers that need a decimal place. So I'll add a little comment here. So double is for numbers with decimal places. Okay, so that's the double type. So we'll say double, and we'll call this my pay rate. Now, when we're naming things, a common convention here in Java is called Camel Casing. So my name for it, again, I called scanner keyboard up here. I'm going to call this double pay rate. Every next word is going to get a capital letter. So kind of imagine like a camel with the humps in the middle. Every word is another hump, right, as you go. So this is Camel Casing. So the pay rate equals. Now, you could do keyboard.next double. This is fine. I don't recommend you do it this way, though. So the way that I prefer, or the way I would recommend you do it, so I'm actually just going to comment that out. We're going to say double pay rate equals, and now we're going to need to do some conversion. So we can say double dot parse double. So double dot parse double, you can give a string value, and it will turn it into a double. Parse is the fancy word for like turn into, to convert, to try and read. And in here, then, we can use keyboard.nextLine. Let me see if I can slide this over a little bit. I think you can see all that still, right? It's all good still? So this is my preferred method here. So avoid this if possible. And it's a better way to get numeric input using scanner. And I know it's going to seem like this is not a better way because you have to do a lot more typing. But what happens here when you use next double, it leaves the enter key out. So because it knows only numbers can be doubles, once you hit the enter key, it ignores the enter key and leaves it there. So the next time, if you ever want to go get text, you're going to run into some trouble. Hey, Captain Mean Man, I've got my quad shot here. I'll call this hydration, although some people say coffee and espresso is not hydrating. But, you know, we got a long night ahead of us, so thank you for that reminder. So I'm going to say double.parseDouble. Remember, it is case sensitive. So this is a capital D double dot parse lowercase d capital double. And then inside of parentheses, we put keyboard.nextLine, open close parentheses. So this will get the next line of input, convert it to a double, store it in a location that the operating system gives us, and we're going to call it pay rate. Then we're going to do it again. So now we're going to have a double for hours worked. And it's the same thing here, double.parseDouble, but I should probably ask them to do something, right? So I'm going to use my print line again here. Please enter the number of hours you worked. So we'll say, please enter the number of hours you worked, and then we'll get their input, turn it into a double. Again, double means it has a decimal place. If you only want whole numbers, you're going to use integer. Okay, so integers are great, but you can't have decimal places. And if you work 9¼ hours, you need to get paid for that quarter hour. Right? You don't want your employer stealing money from you. That's not cool. So we'll make sure we get all those fractional quarter hours possible. Make sure you get paid the right amount. And same with pay rate. Right? A lot of times you don't get paid an even dollar amount. So we're going to work with doubles here. Then what we can do is we can have Java do all of that arithmetic for us. So we can say, okay, our double, this is our weekly pay, is equal to, or we're going to assign. Remember, this is the assignment operator. It's going to take whatever's here on the right, assign it to the thing on the left. We're going to take my pay rate times my hours worked. Now, if you have to type all these out, I mean, it's not too hard to type them out, no big deal. But if you start typing a couple letters, it's going to suggest, hey, you want this variable. So even if variables are really long, you don't have to type them all every time. So I want pay rate times hours worked. Semicolon. Right? All of our statements have to end with a semicolon. This is the command to Java. Tells it to do something. It says, okay, multiply those two together. You get all the same arithmetic you can do. You can add, you can subtract, you can multiply, you can divide. And we'll look at some other fun ones in a little bit. We can do all those same things. And then we want to print out. So, oops, nope, that was wrong. Your weekly pay is... Now what I want to do here, excuse me, I want to take one string and smush in another thing. Now, printline is smart enough to know that, hey, this isn't a string, but if you want to add it to another string, you probably should turn it into a string. So it does a little bit of that work for us behind the scenes. It's really nice. So you can add or append things that aren't necessarily strings. Okay, and we'll see if we get the right... I'm going to put a $sign there to make this look pretty, right? Let's run it. Click run, or use my run option up here, right? Or go to the run menu. Always 3 different ways to do everything when you code. Let's see if it wants to cooperate. All right, so your pay rate. So let's say you make $9.50 an hour. Oh, it's not okay. Every so often, it gets really confused with these add-ons. So if you go to your project, right-click the project and go to Properties, go to the compiling section here. You want to uncheck this compile on save. I've never had this work right for me. I don't know why, and it's just awful. So undo that thing, uncheck compile on save. That way when you run your file, it actually compiles. It tries to be too helpful and it just fails. So if it doesn't run everything and you think it should be running more, it's probably your issue. All right, now we get, all right, enter your hourly pay rate. We'll do $9.50. And let's say we worked 32 hours. Your weekly pay is $304. Okay, cool. I think that, let's double check it. Don't ever trust the computer. Let's make sure we did our arithmetic right. So I'm going to open up my calculator. I want this in standard mode. So if I do 9.5 times 32, I get 304. It's working out pretty good. That looks like the math checked out. So we're able to calculate the pay based on whatever the user typed in for us. Right, so whatever your hourly rate is, whatever the hours you worked this week is, fantastic. We can go get those results. Okay? So some of this stuff that happens outside here, right? We can do all this by hand if you want. You can just make a new empty Java file. Sure. And there's nothing wrong with doing it by hand, but I would rather the tool do it for us, and then when we need to understand some of this stuff, we'll get into more. But for now, everything goes inside public static void main string args, this curly brace, and then scroll all the way down to the closing curly brace here. In my case, it's at line 27. And now it's really handy. When I click on that curly brace, it highlights and says, oh, hey, up at line 7 is where this thing starts. Just from clicking on it, kind of pops up that preview. So it's trying to help me see, hey, this is where everything is inside a main. Okay? Now, class names should start with a capital letter. And you don't ever want to use spaces. So when you're naming projects, the name of the class is the name of the project. So notice my project was called Chapter 2 with no spaces. Your class name is Chapter 2 with no spaces. So avoid spaces. Spaces confuse Java. And now if I come back over to my GitHub client, it's going to say, hey, you got a bunch of new stuff here. Right? Again, all these build manifest, NB project files, no big deal. It's all my NetBeans stuff. But chapter2.java, that's the one I care about. I can see in plain text all my code here. So this is my pay calculator. Done. So that's my commit message. Commit will take a snapshot. It's got everything inside this folder at this point in time. Now I need to make sure that I'm in sync with the remote or the central repository, the origin repository here on github.com. As soon as I've synced, and it has to think a second here, I should be able to see it online. So I'm going to go to repository, view on GitHub. And let's grab this one. Oh, it opened the tab up over here. Bring it down here. Wrong window, wrong monitor. And now you'll see there's a folder for chapter 2. And I can click on that folder, and I can then browse around inside of source or SRC, and inside of chapter 2. I see there's a chapter2.java file. And I can click on that, and I can actually see the text of it here. So it's a little small here. I can zoom that in. Enhance, enhance. Okay. And you can see all this. So all the code examples I do in class are going to be out here in this code, this public repository. So let me take that link and I'll push that out into D2L here. Grab our D2L page. We go to course information. I'll add that here to the course information. So we'll make a link to our course repository. Okay, so if you ever want to go find any of the code examples, they'll be out here. You can just follow this link in D2L, or you can go right to my GitHub page, whatever works out for you. Most people have trouble spelling Charnesky. All right, you folks still there? Maybe you need a quick little coffee break. All right. Things are looking pretty stable. All right. Still no frames per second, but I think it's just confused about that. The folks said it was working okay. All right. Awesome. We're in pretty good shape. All right. Awesome. So our class names, don't worry too much about the namings for them other than capital letters. This is pretty PogChamp. All right, pick. Glad it's working out all right. So again, usually we'll use doubles because if we need a number with a decimal place, that's fantastic. If we want to use some integers here, now we use, it's the type called int. So int is short for integer. Or integer. Remember, integers are whole numbers. Whole numbers only. Right? No decimal places. So if I have an integer, then I can do something with it. So we'll say, hey, int, let's do, we'll call this one, hey, all the smiles in chat. I love it. Do an int for, boy, what integer do we want to store? How about number of class meetings? Again, long, but you know, hey, the name of it should tell you what it's being used for. So we'll have a number of class meetings. And, oh, I need to prompt something first. So let me say, please enter the number of times the class meets. Again, that's a little bit long. I have to scroll left and right, but I'm zoomed in a whole lot more than you probably are. A general rule of thumb is you shouldn't have to scroll left and right to see all your code. Again, mine's a little bit zoomed in, so I'm not too concerned about it, but like if I have to scroll and scroll and scroll and scroll and scroll, it's bad. But if you want, right, NetBeans is really helpful. You just come into the middle of your string here and hit enter, and it's going to say, oh, you want to take this string, concatenate. Remember, it's not really addition when you have a string. A string plus a string doesn't, you're not adding anything, you're just sticking them together. That's called concatenation. It'll do that for you. So if you ever want, it's usually really good at figuring that out for you, and then you don't have to do your own whatever. Right? And as long as this parenthesis has a matching ending parenthesis, and then you have a semicolon, Java doesn't care if you put like one word per line. You know, I will tell you people care, like I care. This is horrible to read. It's just awful. So like, don't do this to people. And the code is for people, right? We write code so that other people can read it. So especially even though so you can read it. And I tell you, your memory might be really good now, but you know, if you write some code and you use some terrible variable names and then you come back and Comcast said, nah, you come back tomorrow or the next day or a few days later and you're looking at it again, it's really hard to remember what you were doing if you use terrible names. Again, like this could be W, this could be P, and this could be H. Java's not going to care if we call it that, but I care and you care because I don't know what those mean, so use good names for it here. And we'll do the same thing here. So if you want an integer, we're going to use integer.parseInt given keyboard.nextLine. So this is how we can grab integer values here. Okay, and then we'll ask them, please enter the number of credit hours for the course. And again, sure, that's a little long, so I'll just come down a line. No big deal here. And I'll have another int. So I'll have int credit hours. Or how about course credit hours, be even more specific. And then I'm just going to copy paste this line. Right? No big deal, just copy paste it. Control C for copy, Control V for paste is your friend. Okay? And then we can, we'll have, before we print anything, sorry, we'll have an int for total contact hours is going to be my number of class meetings times the credit hours, or course credit hours. I can say total in-class hours plus total contact hours. So we'll ask them, and we're going to use some integer values here for, okay, how many times does it meet, and how many credits is it? So we give this a run, and we should be able to do both things. All right, so we'll do 950, sure, 32 hours, okay, and the number of times the class meets. So we're going to meet 15 times for 4 credits. We should have total in-class hours of 60 hours this semester, right? And that arithmetic, I think we can just check out in our head. 15 times 4 looks pretty good. All right, you'll notice we're doing a little bit at a time and running it, a little bit at a time and running it. That's what you want to do when you're working on your assignments too. You want to write a little bit of code and run it, make sure the little bit works. If you just try and write everything down to solve the entire project, and then you hit run, and it doesn't do exactly what you want, it's going to be really hard to find out, well, where did they go wrong, right? Exactly what point was it not working where I wanted it to work. Okay? And then we want to practice using our debugger as well. So not only can we run stuff, we can debug our program. So I'm going to come in here and say, hey, let's pause at line 22. I'm going to just click on line 22 and I get a big fat red square. That's a breakpoint. So instead of hitting run, I want to debug. So in debug mode, Java's going to pause here, and actually I can see the value of all of my variables and see what's happening behind the scenes. It's super cool. So right now it doesn't look like we got anywhere because when you use this keyboard next line, it's going to wait. So I need to go back over to output. Oh, I think it's still connecting. It's thinking hard. All right, so I'm going to come back over to output. Please enter your pay rate. So I'll say 9.5. Okay, now you see I get the green line. So now Java is paused. So it ran this line, please enter the number of hours you worked, and it's waiting at this line to do something. So in debug mode, we have these couple arrows. Most of the time, we're going to use this step over arrow. This one means, okay, run that line, go to the next one. Run that line, go to the next one. Excuse me, so I'm actually going to step over. Now it's going to sit and wait a second because it's waiting for this keyboard next line. So let's do 32 hours. Now the next line that's ready to run is line 24. So this green arrow is telling me, okay, I'm about to run this line. Now I can come back to that variables tab and I can see, hey, pay rate is 9.5, hours worked is 32. That's really tiny on my screen, I'm sorry. But what's fun is I can go in and change it. So I can change my pay rate, let's say 25 bucks an hour. I'm going to go change it here. Cool. And then if I'm done, I can just hit continue, it'll run to the end, or I can keep going line by line by line. I'm just going to hit continue because I want it to just go to the end here. I'm going to come back to output. So, oh, what happened? Well, it's not 9.5 anymore, right? We changed the value, so 32 times 25 works out to be 800. Is that right? Probably is. I don't know. Let's check the math real quick. 32 times 25. There we go. 800 bucks. Cool. And then again, all right, we meet 15 times. We have 4 credits. So in debug mode, you can pause it and it'll wait for you, so you can actually see the value of all these things we're calculating. And you can see what's happening, and maybe you might catch, oh, I had an arithmetic error. So maybe instead of multiplication, maybe I did addition, right? And that's going to give me the wrong result. Again, some of that stuff might be easier to spot than others, but using the debugger, you can see step by step by step by step what's happening behind the scenes. It's super cool. Right, so most of the time, we're going to use doubles for numbers with decimal places and ints for numbers, whole numbers, integers and doubles, numbers with decimals. There are other types in Java. There's a thing called a float. A float is less specific than a double. So a double can have, I believe, like 15 numbers after the decimal place that Java will track, and it can be really big. Floats are half that size. I think you only get 7 numbers after the decimal place. The reason why I don't like floats is they're annoying. So if I were to just declare my own here, so instead of using some input, if I just wanted to say, hey, double some number equals 4.2, perfectly fine, right? If I wanted to use a floating type, and this was other, or I don't know, we'll call it float number, and I said, hey, this one is going to be 7.7, it's going to yell at me right now. And this is why I hate floats. And it says incompatible types, possible lossy conversion from double to float. So when Java sees a number with a decimal point, it assumes it's a double. If you really want a literal number here, so literally mean when you're actually putting it into your program, you've hard-coded it in, the numbers in your code, if you want it to be a float, you have to add the letter F to tell Java, yeah, I really want this thing to be a float. That's the entire reason I hate floats. They're obnoxious. Now, sure, technically, a float, because it is smaller and less precise than a double, can be stored using less memory, which is a good thing. There's optimizing and saying, let's use the least amount of memory possible. Fantastic. Most of the time, we could care less, right? Computers have so much memory nowadays, we don't care. And sure, that's a little lazy, and I apologize, but this is our very first programming class, and we're not doing anything where I have like 1,000,000 floats versus 1,000,000 doubles, because that's the scale that matters, right? A kilobyte of memory is 1,000 bytes. A megabyte is essentially 1,000,000 bytes. It's usually by powers of 2, and it gets weird like that, but that's fine. So you have 1,000,000 bytes in every megabyte of memory, and our computers have gigabytes. So that's billions of bytes of memory. So if we're going to use, 8 bytes instead of 4 bytes, or, I don't know, hang on, let's Google it here. Java size of float versus double. Let's check it here. Oh, here comes the rain. There we go. So a float takes 4 bytes. Great. A double takes 8 bytes. So if we're going to use 4 extra bytes to store a number, it probably doesn't matter because, again, I've got millions and millions and millions of bytes of storage, and unless I'm doing this at like a million scale, we're never going to notice the difference. And yes, that's lazy. I apologize, but that's, I mean, it is what it is. And this is our very first class. When you take an algorithms analysis class, then you look at, yes, why is it important that we optimize? Perfect. That's wonderful. Take our data structures course. We'll talk about optimizations. Nothing wrong with it. But at this point, trying to make sure that I'm using the smallest possible value to store things is a little silly. So doubles and floats. And now there are also different values, different ways of storing integer values as well. If you need something, so an int here, and this is actually interesting, an int takes up 4 bytes of memory as well, the same as a float. Now, integer values can only get so big because it's stored, everything is eventually stored in binary. So let me open up my whiteboard here. Binary is fun. Oh, look at that. We were just talking about this in the other class. So our normal number system, right, is considered base 10. So if you look at like the number 4,321, the value of each of these, right, this is the ones place, this is the tens place, this is the hundreds place, this is the thousands place, right, each one of these. What it actually is behind the scenes, because this system is base 10, it is 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. So each next place value is 10 to the next power. right? So we get thousands, 10,000s, 100,000s, millions, billions, 10 billions, 100 billions, trillion, on and on and on and on and on. It's always the next 10 to the what. So that's the base 10 system. That's our usual system. Binary is done in base 2 because you are either on or you're off. So the only value you can be is a 0 or a 1. When we store information, you're either yes or no, right? You're on or you're off for this individual bit. And we're going to put all these bits together. So a bit is either a 0 or a 1. That's all it is. So that's base 2. So if you put enough of these together, you get 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 7 here. So each one of these place values then represents 1, 2, 4, 8, 16, 32, 64, 128, and on and on and on and on. But you can get bigger and bigger and bigger. So if you want to represent a number, you toggle or you turn on one of those bits that will add up to it. So the number 1, or the number 0 is just 0. The number 1 is 1. But then 2, I need this value here. So I'm 1, 0. So it's 1, 2 plus 0 ones. Right? That's 0, 1, 2. 3 is 1, 2, and 1, 1. 4 is 1, 4, 0, 2s, 0, 1s. 5 is 1, 4, 0, 2s, 1, 1. 6 is 1, 2, 1, 4, 0, 1s. 7, 1 of each. 8 is 1, 8, 0, 4s, 0, 2s, 0, 1s. Right? On and on and on and on and on. We just keep on going. So what we do was with an integer value, we have 4 bytes. And a byte is 8 bits. So byte equals 8 bits. So like 0, 0, 0, 0, 0, 0, 0, 0. Great, that's 8 bits. Now an int is 4 bytes. So we get 32 bits. So the place values then, right, are going to be from 2 to the 0 up to 2 to the 31. And if you open up your calculator and you check out what is 2 to the 31, so I need, not this one here. I need the scientific calculator. I need 2 to the 31st power. 2,147,483,647. 48. Sorry. That's 2 to the 31. So that is the value. If that one is on, that's the value represented there. Now what's really cool is the calculator actually has a programmer version here. You can do decimals or you can do binary notation. This is common enough, and you can even put it in this bit toggling mode, which is my favorite. So you can turn on individual bits. So all 32 bits here. So these 4, 4, 4, 4, right, on and on and on. If you turn on all the bits here, we get the value of 1 less than the next one. And hopefully you saw that pattern. If not, don't worry about it. It's not too big of a deal. But if I turn on all 31 bits, I get 2,147,483, no, 2,147,483,647. This last bit here needs to be saved because integers can be positive and negative. So I get to use 31 bits to store my number up to 2 some odd billion and 1 bit for positive or negative. Okay, so the maximum value of a Java integer is 2,147,483,647. And there's actually, you can print that out if you want. There's this integer dot max value. So, and we'll do, let's say, max value of an int. And we'll just concatenate that together, right? Put it all in one line. Let's see if we did our math right here. Oh, sure. So I'll just put in a bunch of ones here. Okay. 2,147,483,647. That's the max value of an integer. If I want to take that plus 1, like that, max value plus 1. It's a good question. Cirimo? I don't know if I'm saying your handle right. So we'll do some ones. Now, what's funny here, because println is really good at saying, oh, you want a string and an integer, you must really want that integer as a string. It really did this string plus this string, so it just added a 1 to the end. If you want the arithmetic, you need to put it in parentheses to force the order of operations. Okay, so I'm going to add another set of parentheses to force order of operations to say, hey, add this together first, then spit it out. So we'll do a bunch of 1s for our other example here. And look at that. 1 more than that is a big old fat negative number. Uh-oh. That's bad, right? Going above the max does really weird bad stuff. And it doesn't even crash on you. You just get funny results here. Isn't that neat? Okay, so I'm actually going to undo that if you don't mind, because that is, makes the example look really funny. Okay, that's a good question, though. So we can use integers up to a certain size. Most of the time, 2 billion should be enough. If you need something bigger than that, there's a long. So long is a really big integer value. Some big integer can be really big. Hey, here come the bots. Let me get out the band hammer real quick. Just give me a moment here. Goodbye. Man, I really do want to be famous, though. Could I buy some followers? Do you think that would work? All right. I don't know who actually clicks on any of that nonsense. That's just silly. All right, so a really big integer here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. Integer number is too large. All right, it's too large for a long. Uh-oh. What? What do you mean too large? Still? No, you gotta be kidding me. Come on, let me put in a long value here. We need to tell it it's a long. My goodness. Come on, Java. Cooperate. All right, I'm failing at my example here. My apologies. Nope. All right, that's okay. You know what? Let's just Google. Let's just Google all the long values. Google's your friend sometimes. Ah, capital L for long. There we go. Ooh, my maximum value here. So let's see. So this is 10 or hundreds. That's thousands, millions, billions, trillions, quadrillions, 9 centillion? No. Centillion? Centillion? I think that's a 5. Right? Okay, so 5 centillion here, there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Long. And now what's really cool in Java, now you can't put commas in because commas will confuse Java. Right? It has no idea what to do with commas here. What you can do is you can put underscores in your numbers as separators, and Java is perfectly fine with that. 9 centillion lines of code. There we go. Like, I could write a program that would write that for you, but I'm not writing that by hand. So here's ones, thousands, millions, billions, trillions, quadrillions. So we have room for one more digit if we really wanted. So really big, right? As opposed to our integer max value. Okay? Bigger than that, and there's actually other things we can do. We don't need to even bother. But these are called primitive types. So these are lowercase types here. These are built into Java, and primitives are handled specially. But we get all sorts of fun things. So if we have some integer values, we can do arithmetic. We can add, we can subtract, we can multiply, we can divide. Now, you probably have seen these sorts of silly things out on Facebook, or all the cool people use Instagram nowadays, right? Facebook's for old people like me. But they'd say, hey, what's the value of, what do we do? 5 plus 20 divided by 10 times 50 minus 50, or something like that. You ever remember seeing these things? And if you think back to your math classes, remember there's this thing called order of operations, or PEMDAS, or please excuse my dear Aunt Sally, or whatever you want to call it here. So order of operations still applies. Now, some people get confused because apparently we teach it badly. So we say parentheses, exponents, a multiplication, division, addition, subtraction. Right? That's our PEMDAS, right? But just because you say multiplication before you say division doesn't mean it happens first. Right? Multiplication and division have the same order of precedence, the same level of precedence. So you read those left to right. Okay? Addition and subtraction. Same thing. You don't do all of your addition first and then do your subtraction. They have the same level of precedence. You'll do them from left to right. Okay? So what we would get here is 20 divided by 10 is 2, times 50 is 100, 5 plus 100, 105, minus 50, 55. Sorry, I don't have any socials. I think they're just linked to my profile if you just scroll down a little bit on the channel here. So this result here then should be 55. So I'm just going to take all of this, put it in text here then, and we'll say equals, and I'll append in my result. Right? Should be 55 because the order of operations applies. If you want something to happen first, use parentheses. Right? I'll just throw in some numbers here. Sure. Right? Order of operations applies. So multiplication and division have the same order of precedence. Whatever, you just read them left to right. Okay? Hey, yeah, there's my Nightbot commands. Awesome. Actually, I do need to update those too. I have the old book in there. I have to add the new book. All right, so order of operations applies. So that part makes sense? Is that okay so far? All right. Some people get mixed up with that, and that's okay. All right, awesome. Now, a funny thing in Java land, when we're dealing with integers, so if I have an int, I'm going to call this integer division is weird. I'm going to say 5 divided by 2. And if I print out 5 divided by 2, integer division is weird, I'm going to get a whole number. Because remember, integers can only store whole numbers. Right? So 5 divided by 2, if I can only store whole numbers, I'm going to lose the decimal place. So 5 divided by 2 with integer division is going to be 2, because I don't have room for that half. Right? There's no place to store that half here. So the decimal is truncated or just gets lost. Right? Any decimal remainder is gone. So what you might think could happen is say, oh, well, let me just store it as a double here so I can keep the decimal value. Right? That's a good thought, right? Hey, I have room to store a decimal value now, so let's do 5 divided by 2, store it as a double, and see what I get. Still get 2.0. So I have a decimal, but it's still 2. So if you have an integer divided by an integer, the result of that is an integer right off the bat. So even though you're going to store that in a double, you're storing the number 2 as a double because there was no decimal in the arithmetic. So if you want this result to happen here, right, this side or this side needs to be a double. So to keep the decimal result, use a double on one side. Look at that. 5.0 divided by 2. Goodness, that's long, but sure. So that's 5.0 divided by 2, plus this really long variable name here. Right? You know what that means. Okay? Now let's run that. So now if one or the other of those operands is a double, the whole result will be a double. So you got to be really careful if you're doing integer division. Okay, now I get my decimal because I had a double in the operation. Okay, so just storing it as a double doesn't work for you. You gotta be careful with that. All right, cool. String appending, awesome. Now, people in Java land, the fine folks who write the Java language for us, know that us developers are lazy, and we'd rather do something with some shortcuts. So if I have an int, I'll say value equals 1, and I want to change that value, right? I don't need to tell Java it's an int again. I can just say value equals value plus 10, right? This will take the current value of value, add 10 to it, assign it back to value. So value is going to start at 1, so I'm going to say value plus value. I'm going to add 10 to it, right? And the value now should be 11. Cool. So we can add 10, save it back. Okay, so when we add 10 to it, great. Works like that. We could subtract from it, we can multiply, we could divide, we could do any of our arithmetic, but we want a shortcut. So I want to say, hey, instead of saying equals value plus 10, that takes too much typing. I can say plus equals 10. And this will say, okay, take the value, add 10 to it, and then assign it back. So this is a combined assignment operator. It's just a shortcut. This is our shortcut, combined assignment operator, a shortcut of above, right? Excuse me, does the exact same thing. Takes the value, adds 10 to it, and then assigns it back. So now it should go up 10 more. All right, pay rate. Yep. Okay, it went up 10 more. Now, what you have to be careful of is you can do this as well. You can say value plus 10, and then remember, force your arithmetic, right? If you don't put the parentheses in, it's going to say, hey, string plus number, that number must be a string, plus a number, that must be a string, and turn them all into strings. So this will add 10 to value, but then if I print out value again, because I never assigned it back to value, value is not going to change. So this will do the arithmetic, but it's not changing the value stored here. It's just taking this value and adding 10 to it. This value doesn't change here. We're getting like a new number because we're doing the arithmetic right in there. So I go up to 31, but value is still 21 because I never changed it here. So you have to be careful with those. Okay? So that's our combined assignment operator. You can do this with any of the arithmetic operators, with plus, with minus, multiplication, division, right? All perfectly fine. Right? When we're dealing with strings, oops, my goodness. There's some cool things you can do. Remember, it all has to be inside a quote. So if I want another quote in here, so we'll say like, Simon says, quote, take a break. End quote. Ugh, that looks really ugly, and now I get all these red lines. So what you have to do to tell Java, hey, I really meant to quote, there's a special character called the backslash. So the backslash is the escape character. It means, hey, a special thing is coming next. So we use backslash with a couple different things to represent special things. So backslash quote means, hey, I actually want the quote mark inside of my string. Okay? You can do a backslash n for new line. You can do a backslash t for tab, a backslash r for carriage return, which is essentially a new line but funky. If you want the backslash character, you need two backslashes. You say backslash. All right, so you can look those all up in the book. So you can do cool things. Tabs are nice for like making stuff look nice. But let's see what Simon says here. Make sure that comes out okay. Pay rate, yep, hours work. I'm just putting in a bunch of ones for now. All right, and now we get our quotes out. Simon says, take a break. All right, so I've been talking, I think I've been on for about an hour now. So let me throw some music on. We'll take a 10-minute break. Go out and stretch, get some more coffee, whatever you got to do. We'll come back. We probably got another, let's see, how far did we get? We're not doing too bad. We're maybe a third of the way through. So we got at least another hour of working through some examples as we go. And then we'll talk about the project after that, okay? Put your music on. Hey, folks. All right. Hopefully I had a good chance to go get stretch a little bit. Let's see. Pause that. Maybe we'll come back here a little bit. Music's not too loud, is it? I think I can tweak that pretty well. All right, I got my commands updated here for book. Let's see. I think everything else should be fine. Oh, yeah, I'm not using no copyright sound. What am I using here? Oh goodness, what is it called? Shaping the silence. Right? I think that's the site. Yeah, shapingthesilence.com. No, yes. Okay. We fix that one here. Goodbye. I used to use the no copyright sound on Spotify, but it had ads, and then the ads just got obnoxious. And I'm too cheap to pay for Spotify Premium, so. Alright. Excuse me. I also have a friend of mine is in a band, but they're real heavy metal, death metal, so it's the vibe's a little different for using that, so. Alright, so we're going to pick it back up with more stuff for writing our first Java programs. We should be able to get through that, and then get into our next assignment. So I'm going to make another commit here. So the only file that should have changed was chapter 2 Java. Right? Red means it was removed, green means it was added. Oh, sorry. Excuse me. So chapter 2 examples. And the extreme coding vibe, yeah. What the death metal. I mean, there's a time for it, but I'm not sure, like, getting ready for class or, like, on break on class is right for that, but... Alright, so commit. We'll make that snapshot of this file, this point in time. Come on, commit. I'm gonna close that down. I don't know, is it being slow? It's slow. Of course it's slow. Oh, and I gotta go back. I deafened myself here, just in case anyone was in voice chat. So I should be back. There we go. So if you want to hop into voice chat, should be great. You should be able to chat, just like talk at me. Should work out pretty well. Come on, what are you doing here? Let's go, GitHub. There it goes, and I can push. And then you'll see all those examples out online as well. It's just running really slow. What else is it doing right now? Are too many windows open? Inspector's fine, cool. Move that there, awesome. And download more RAM, yeah. There we go. That's just OBS with being a hot. This desktop window manager. My edge tabs is using up so many? Alright, I can close some of these edge tabs, that's fine. If that helps. Guess we don't need the inspector right now. Alright, that's a little better. Got a little more room here, I think. Alright, not too bad. Not too bad. Yep. Alright, cool. Alright, so we listened to Simon Says, we took a break. Some other cool things. So we looked at this importing java.util.scanner. Again, I prefer this import. It's a little easier here. If you don't want to do all that typing, what you can do is when you create your scanner, we can say scanner, another scanner, the new scanner, given system.in. If you don't want to have that import line, you can in here type java.util.scanner and specify, hey, I really want it from this Java utility package. Again, I'd rather just use the import, but import is easier. But whichever way, perfect, they both work, no problem here. And there's a lot of cool packages we can use in Java. So if you want, like, the date and time, is a really cool package. We could say, hey, I want a date now equal the new date. And Java would say, I don't know what a date is. Right? Cannot find symbol. Okay, well, let's go to our suggestion. Do you want to import java.util.date? Yes, we do. Don't click these other ones. These other ones are bad. Okay? Just the first one. So a date in Java will, without giving it anything, will give us when now is. Right? So this is the current date and time. So I can print out it is currently plus now dot toString. So now dot toString is going to convert this date to a string here for us. That's really nice. And again, it just adds an import up at the top. Right? All your imports go up at the top. Java.util.date. All right, enter our numbers. We'll just do a bunch of ones. And now we get Tuesday, September 7th, 1935-27, Eastern Daylight Time, 2021. Ooh, look at that. Isn't that a pretty date? Okay, so if you're not sure how to use some of these things, there's the Java API, or the Application Programming Interface, you can go check out. So if you just go Google, and grab another window here, look up Java API, and let's look up date. Version 8 is the latest official Oracle version, so we're going to use our Open JDK is built off of theirs. So we can look up date, and we can see all the things to do. So if you want to create a date, you can give it a year, a month, and a day. Sure, we could do that. Or a long with a millisecond time. That's kind of silly, but you can do that. You can get the number of hours, you can get minutes, you can get seconds, you can get it as a string, you can convert it to local dates based on given timestamps. You can do lots of cool things with date. Right, you can try and get the date from a string value, which is fun. So it tells you all these things you can do and gives you examples here. So if I want to set the date given year, month, and day, I'll say, hey, okay, let's do, what? The year minus 1900? Okay, that's funky, sure. Month 0 to 11, that's annoying. All right, those look obnoxious. A long millisecond, those ones are, trying to do milliseconds are silly. Set, you can get the value of, right? You can turn it into a string. This is the nice long format. Sure, you can do all these cool things. So this is the Java API. You can look up just about anything you want in the Java API. If you go to like overview, these are all the different packages we get in the Java API. Tons and tons and tons of different packages. Lots of really cool things we can do. Okay. All right, here we did scanner. Again, next line is going to work best for you when we use scanner, and then just do your conversions. If you don't, it's going to leave that enter key on the keyboard and it's going to cause all sorts of problems. So don't worry about that. Look at that. Yeah, we're doing great here. All right, so we've done our arithmetic operators, right, with multiplication, division, addition, subtraction, those sorts of things. Now, there are relational operators to say, hey, does this thing equal? Does it not equal? Is it greater than? Is it less than? Uh-oh, did my camera freeze? Looks like it froze on my computer. Maybe it didn't freeze on mine. That's funny. I don't know if I can turn that. Yeah, it froze. I wonder if I can turn that on and off. Oh, nope. It just hides it and unhides it. If I go from one scene to another. Nope. Camera's still frozen. That sucks. Can I reset it? I don't actually know if I can reset that or not. Deactivate? Activate. Aha! That worked. I have to defrost it. There, is that better? I think that worked. Look at that. I've never had to do that before in OBS. We're learning things, folks. We're learning. Set the camera to 350. You want it to melt? All right, so we can look at relational operators and say, hey, are you equal to? Are you not equal to? Are you greater than? Are you less than? Greater than or equal to? Less than or equal to? And all sorts of cool operators. So we can say, hey, let's print out, I don't know, let's enter a number, and then we'll get an int for first number equals integer.parseInt given the keyboard.next line. Oops. Right, and then we'll do the same thing again. I'm just going to copy paste, copy all of that. Enter another number, and then we'll say, hey, this is second number, integer.parseInt, and then we're going to say first number equals second number. Number colon, there we go. First number equals second number. We bump that down a line. Put that in more parentheses. Okay, so I'm going to force that order of operations to say, hey, do the equality here. Do you equal? Okay, we can do that with equals. We can do that with not equals. So not equals is exclamation mark equals. Remember, a single equal sign is the assignment operator. So I can't use a single one because that'll try and assign. I need to use a double equal sign here for testing equality. We can do not equals. We can do greater than. We can do less than. And you can also do greater than or equal to or less than or equal to. Those ones aren't as oh sure, we'll do them anyway. They're not as interesting, but why not? So less than or equal to, just make sure you do it on the right side. It's always greater than or equal to, less than or equal to, not equal to greater than. Right? But the equal sign goes on the right. Okay? And what this is going to give me, this is either true or false. Right? This is called a Boolean expression. It is either true or it's false. There's no in between. Either it's yes or no. Right? So when I run that, let's give them some numbers. So enter pay rates, other numbers. Okay, enter a number. We'll do 42 and 77. So they are not equal, false. Or equals, false. That means they are not equal. Not equal is true. Yes, they are not equal. Is first greater than second? No, 42 is not greater than 77. Is first less than? True. Yep. Is it greater than or equal to? False. Is it less than or equal to? True. Okay, so we get these results back out. I'm going to add some more spaces here real quick. Just make that look a little prettier. Okay. So we'll compare. So this is ways to compare numbers. Okay, that's a Boolean expression. Now, when you're comparing strings, right? Maybe we say enter a name, and we'll have a string for name. It's keyboard.nextLine, and then let's do it again. Enter another name, and this will be another name. Sure, why not? Another name, and this is that camel casing, right? The next word gets a capital letter. Now, when you're comparing strings, you don't want to use the equal sign. The equal sign doesn't work for strings. Use for strings. That's no good. So what you do instead, you would say first name dot equals another name. First name dot equals another name. And we need some order, more parentheses in here, right? So, oh goodness, did I do too many? Oh, not first number, no, name. Sorry, name equals another name. It gave me a weird error here, that first number, when I had first number, it said int cannot be dereferenced. You can't use dot equals with an integer. Right? It just doesn't work. Okay, so that's that error there. So name dot equals another name. That's name, not first name. Okay, we can check do they equal each other. You can check if they don't equal each other is funny. We have another operator, like when we had not equals. This is the not operator. We would say, does not name equal another name? So you don't say not equals, so you don't put it here, you put it there. So this, not. So not is the opposite. So if this is false, not false is true. If this is true, not true is false. So that's the not operator. The not operator. It flips true and false. Right? By flips, it means like not true is false, not false is true. Right? Not true is false, not false is true. And I forgot, I have a funny t-shirt for the programming or ACM club. It's like the computer club over at Dearborn. That actually says not false. It's funny because it's true. It's just a silly t-shirt. But it would have been a good day to wear it. Unfortunately, I wore it yesterday. All right, so we'll throw some in here. Now, all right, number and number. Now we get, hey, they're equal because I did 1 and 1. All right, enter name. Let's do Eric and Eric. Uh-oh. Not equal. Not equals true. So Eric lowercase e and Eric uppercase e are not equal. Right? They're different because Java is case sensitive. So if you want, you can do equals ignore case. So we can check the casing on this. Let me go a little format. We'll say equals ignore case. So equals ignore case, then we'll ignore case errors or case differences. Right, so then uppercase E error should be equal to lowercase e error because we're ignoring the cases. We're ignoring uppercase and lowercase. 1, 1, Eric and Eric. Now we get equal ignore case true. That is true. Yes, they do equal if we're ignoring the casing, the case values there. Okay, so all of this is useful to let our code make some choices. So right now the code only does what we tell it to do from the top to the bottom. Right? It starts up at the top and runs every single line and does everything we've asked it to do. Right? But maybe we wanted to have some decisions, right? So maybe we want to say, hey, let's have a string for is it raining equals keyboard.nextLine. Oh, we should ask them first, right? So we'll print is it raining out, and we'll get whatever they typed in, and we'll store that is it raining. We can say if. Now, if gets a set of parentheses. What we put inside the set of parentheses needs to be a Boolean expression or a Boolean value. It needs to be true or false. If it's true, then we're going to have a set of curly braces. Everything inside that set of curly braces is going to run. So we'll say, is it raining? Equals ignore case. So what I was doing there, sorry, I got to show you all these shortcuts. I hit dot, and it gives me, these are all the things you can do. I just type in a couple letters, and I get, hey, equals or equals ignore case. I can arrow up and down. So I arrow down to equal ignore case, and then enter or tab will autofill that here. Say if it equals yes. I had too many parentheses there. So I'm going to say, hey, is it raining dot equals ignore case y. If you entered y, okay, let's do this thing. So if it's raining, or maybe we'll say yes. Maybe they type in yes. Right? And maybe we should ask them. When we prompt them, we'll say yes, no. Like tell them, hey, I expect you to type in yes or no. So if they enter yes, then we're going to say, don't forget your umbrella. Okay, so if it's raining, right? If is it raining equals ignoring case, the word yes, then we're going to do this thing here. What's cool with if statements, then we can also have, well, if it's not true. So this will only run if it's true. We could say if it's not true, I can say else or otherwise. So if this is true, do this, else do this. What do we want to print here? So if it's not raining, we'll tell them you should bring your gym shoes. I don't know. Sure. That way they can go running, right? I got all my running gear on. Hopefully I can go run tonight if the rain stops. So I'll bring my, I'll say running shoes. Running shoes. So now our code is going to make choices. Our code will have these decision points to say, oh, if this is true, this one runs. If it's not true, this one runs. And everything inside this block of curly braces will run if this is true. You can have as many pieces of code inside of here as you want, right? Just like we've had tons and tons of code inside of main, or like a line 100 something already, or inside the else. So we get to make our choices here. So if some value here, and we can use equals, we can do those greater than or less than, we can compare numeric values, we can do all sorts of fun examples that our code can do different things based on the result. Okay, so enter our pay rate. We'll say 9. Oh, that's right. I was just doing all the ones here, right? 1, 1, 1, 1, 1. Enter a number. 1, 1. Name Eric. Name Eric. Sure, they're the same. All right, is it raining out? Yes or no? We'll say yes. Don't forget your umbrella. Right? And now, if we're not sure, right, we can watch this in debug mode as well, and we'll see that it'll go into this line of code here, into this if statement, which is really cool. Now, technically, if you only have a single line here, these curly braces are optional. I'm going to tell you, always, 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 always use curly braces for your if statements. It's just a good habit to be in, even if you only have a single line of code. Now, you folks probably don't remember, but it's probably been actually like a decade now. It was a long time ago. There was an issue with the Safari web browser, and our fine folks over at Apple had a security vulnerability where if you tried to go to a secure website, people could do a nasty thing and make it not actually secure. The reason that happened was they had a bug in their code where someone did not use curly braces. And what happens if you don't use curly braces is only the first line runs. So only the first line is associated with the if you don't use curly braces. And anything else after that will automatically run. So you just be careful. Just always use your curly braces. It's always a good habit here. And we should be in good shape. Okay, you could do more things as well. So let's do, say, we'll say enter your percentage score 0 to 100. And then I want an integer value. This will be the score. And that's integer.parseInt given the keyboard.next line. Now what's cool is you can have a bunch of these statements all together. So we can make a chain of them. So I'll say if my score is greater than or equal to 94, then what do I want to do? I'm going to print out you get an A. Then I'm going to say else, so if it's not greater than or equal to 94, else if your score is greater than or equal to 90. I'm going to add an else if. So this is if this is true, if not, is this one true? With a bunch of these all chained together here. Then you get A minus, and then I'll do another else if. We'll say, okay, and then if it's greater than or equal to 87, you get a B plus. Else if it's less than or equal to 84, you get a B. Right, well, that should go here. Right, else if it's greater than or equal to 80, you get a B minus. Right, so you can put as many of these things together as you want here. So now I'm going to have 77, 74, and 70 is going to be a C plus, a C, or a C minus. 67, 64, and then this last one I don't need an if. It's just the else. I guess that's not and B and C. Oof, that's ugly. A. I guess that should have the A. But and F, right? Isn't that right? And F. You get AF, a D, a C, a B, but and A? I don't know. You get AF? You get and F? I don't know. I'm bad at English. But now here I have a chain of if-else statements. This is a chain of if, else if, dot, 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 with a last else. So this last else we might call like the default case. So if none of these other ones are true, this last else will run. So elses are optional. You don't have to have elses here, only if you want them, right? Elses, it's completely optional. Optional. You don't have to use them, no big deal. But if you want to, this or this, great. Or this or this or this or this or this. So what happens, because we have a chain of these, they are mutually exclusive. One and only one of these will run. So if your score is not more than 94, it's going to say, okay, is it more than 90? If it's not more than 90, if it's more than 87, we'll get the B+. The rest of these never run because they're attached to the else. So this if was true, this else, and everything else doesn't run. So one and only one of these will run. These are mutually exclusive. One and only one will run. Okay? So we can take a score and turn it into a letter grade. And we can watch that happen. Let me actually hit stop. I'm going to stop that. I'm going to put this in debug mode. We're going to watch this happen. And we can step through with the debugger. So again, put the breakpoint in, you just click on the line number, and then right-click debug, or use the debug. That's the little line number one with the play. Here, I'm going to go back over to output. I'll enter a bunch of numbers. 1, 1, Eric, Eric. Sure, is it raining out? Yes. All right, and here we are. Now we're ready to enter the score. So I'm going to step so that it's going to actually get the input, and we'll say, how about 85? Now in variables, I can see, right, all these different variables we have here. we can see, where's score? Their score is 85. All right, so it's going to say, hey, is score greater than or equal to 94? And we're going to step. That's not true, so it goes to the else. If score is greater than or equal to 90, nope, it goes to the next one. Is it greater than or equal to 87? Nope. Is it greater than or equal to 84? Yes, it is. So it goes into this if block here. We'll see, okay, you get a B. The next step is all the way down at the end. And that was all that was left. We'll check our output, you get a B. So one and only one of those will run. If none of those are true, right, we'll get that else block here. Okay, so then the last thing here we're going to show in chapter 2 is a loop. You know what? Actually, we can talk about it. So a loop is going to let me repeat my code, do something over and over and over and over again until I tell it to stop. Which is kind of fun. So I'm going to say int magic number, we'll say equals 42. We'll pick a magic number. And we're going to play the guessing game. So we'll say, guess a number 1 to 100. Right? So then we'll get an int. The guess is going to be integer.parseInt, given keyboard.nextLine. Now I want to say, okay, if guess is equal to the magic number, we'll say, you guessed it. And if it's not equal to, I want to say else if the guess is less than the magic number, I'm going to say too low. If it's not equal to and it's not less than, it's got to be bigger. I don't need another if here. There's nothing wrong with putting it in, but I know if it's not equal to and it's not less than, you must be too high. It's inside those curly braces, too high. Right? Everything has to be inside your set of curly braces for it to run. So this is only going to let me guess one time. That's not very interesting. So if I want to do this over and over and over again, right, I can put this inside of a while loop. So we're going to say, shoot. Let me do this. I'm going to put my guess here. I'm going to say while guess does not equal the magic number. So as long as you have not guessed it right, and a while loop gets another set of curly braces. Everything that you want to have happen goes inside that set of curly braces. So I'll say, okay, as long as the number is not equal to that, we're going to check. Okay, either you guessed it, it's too low, too high. Then we'll ask them to guess again. So I already told Java that I have an integer called guess. So I'm going to ask them to enter the number again. Now I'm feeling a little bad here, but that's okay. I'm going to do it inside of these options here. So if you guessed it, I'm not going to ask you to guess again. If it was too low, I'll ask you to guess again. If it was too high, I'll ask you to guess again. So what a loop does is it starts at the top, or it checks. If this is true, the loop runs. So if the expression is true, it runs. Once it gets down to the bottom, right, go check if the expression is true, and run again, if it is. It's going to do everything inside of this loop body, this set of curly braces here. And let's see if it's true. So if it's true, it does everything inside of here. We're going to check, hey, is it equal? Is it not equal? Greater than? Less than? Tell them, and then we'll ask them to guess again. If it's not equal to, it runs again. So if they do guess the right number, we tell them they guessed it. So actually, this one here is not great. Let's do this. Let's take this out, actually, and we'll put this down here. So as soon as you did guess the number, we'll just do it that way. We'll say, if you're less than the magic number, else if your guess is greater than or equal, greater than the magic number. So I change my mind. I only want either you're less than or you're greater than. If you're equal to, I don't want anything to happen inside the loop because the loop will stop and then we'll come out of the loop. And now what's fun is we can also track here. We can have an int for number of guesses. It starts off at 1. And every time they guess, here, they guess again, we're going to take my number of guesses. Number of guesses, we'll say plus equals 1. So if they didn't guess it right, we guessed it again. So you guessed it, and we'll tell them in guesses, or number of guesses, right? Number of guesses. We'll tell them, hey, you figured out in this many guesses, right? We're going to start off at 1, because that was their first guess. And then every time they have to guess again, we'll ask them. Great, they did it. That make sense? Now I'm feeling a little bad we have the same code in here twice. We could fix that up later. But let's try it. Let's see if we can guess a number here. So the while loop is going to keep me inside the loop until this is no longer true. And it is no longer true when the guess is the magic number. So I can keep on guessing as much as I want. Rating out, yes, sure. Enter a score, 10, that's enough. All right, guess a number. So if we guess 50, it says too high. 25, too low. 37, too low. 45, too high. 42, we guessed it in 5 guesses. Let's see, was that 5 guesses? Let's see. 1, 2, 3, 4, 5 guesses. Right, it was counting how many guesses it took for us to guess that magic number. Again, not very interesting because we know what the magic number was. Not the most interesting thing here, but that's okay. So the book has a great example. You can keep entering invoices as long as you want, and it will ask you, hey, are you done entering invoices? You can say yes or no. We could say, hey, let's loop until they've entered the word no, I'm all done. Right? If they said yes, let's keep on going. Right? You have more to enter? Yes, let's keep on looping. So this while loop is super powerful, and it lets us do the same thing over and over and over and over again until we decide we're done. So we can also do a thing like, hey, let's say enter a score, or how about I'll just say enter a score. Sure, we'll do this over and over and over. So we're going to say we'll have a string for again equals yes or y, and while again dot equals ignoring case a y. Let's keep on going. So I'm going to start this off where again equals yes here, because I know it's going to start the loop, because this loop here will run if it equals yes. So if it equals yes or y, we're going to keep on going. We'll enter a score, and then we have an int for score is integer.parseInt, keyboard.next line. Now I also need a place. What I want to do is I want to keep a total of these scores. Now it's mad at me. It says variable score is already defined in the method main. So we already have a thing called score. So instead of score, let's do, shoot, what do I want to call it here? I'll call it test score. How about that? Enter a test score. Okay. Now I need a place. What I want to do is I want to add up all the scores so I can calculate an average here. So I'm going to have an int for total score. Starts off at 0. We're going to take that test score, or a total test score. So I'm going to take my total test score and I want to add to it the test score. And then I'll ask them, do you have more scores to enter? And I'm going to tell them again, like y/m. Tell me yes or no here. Right? So as long as they keep entering y, I'm going to keep asking them for more test scores. I'll keep adding it to the total test score. Okay. What I also need is I need a int number of test scores. Right? So every time they enter a test score, I'm going to take my number of test scores plus equals 1. I'm going to add 1 to it. So you add a test score, I add 1 to that. So when I'm done then, I can say the average score is, and actually let me do this over here. I'm going to have a double for average test score. We'll do that arithmetic. Now the problem is these are both double, or these are both integers, right? So the easy way to go about it is I just make one of these a double. Right? As long as one of these is a double, I'm going to get a double result, which is good. So I'm going to take my total test score divided by the number of test scores. And then I can take that value and I can add it here. Right, your average is the total divided by the number of scores. So you can figure out an average test score. So this is going to let me loop again and again and again and again, as long as I keep entering y for yes, I have more scores. I want to continue. Yeah, let's keep on going. Okay, let's try it. So we'll enter a bunch of scores. Sure. 1, yep. Okay, guess a number, 42. All right, we guessed it. One score. All right, test score. Let's do 100. More test scores, yes. Uh-oh. Exception in main. A number format exception for input string y. Oh, goodness, I never changed again. I asked them, but I never assigned again. So, oops, that's my mistake. So it crashed at line. So these are a little funny. You have to read them from the bottom. So at line 194, it crashed, trying to convert y to a number because it was trying to turn that y into a test score. So I need to say, again equals keyboard.nextLine. Right, we need to change the value of again to see, okay, is it a y or an o? Y or an n? That was good. That was a good crash. Totally did that on purpose. Good example. Uh-oh.